Right. Hello, good morning, everybody. This is a fourth lesson from me in the subject uh, Basic Civil and Mechanical Engineering, Chapter 2, that is Surveying, and that one, fourth lesson, that is Leveling, Basics of Leveling, I am going to today. The first topic is definition. Leveling is defined as an art of determining the relative height of different points on, above, or below the surface of the earth. That means the vertical elevations of the points are measured by using the leveling. Horizontal distances already we have studied by using the chain and tape. We can measure the horizontal distances, whereas leveling is used to measure the distances in the vertical direction. That means the elevations of the points can be identified on or below the above or below the surface of the earth. The principle of leveling is to obtain horizontal line of sight with respect to which vertical distances of points above or below the line of sight are measured. Once again, the principle of leveling is to obtain horizontal line of sight with respect to which vertical distances of points above or below this line of sight are measured. The objectives of leveling is: first objective is to find the elevation of a given point with respect to some assumed reference line called datum. So with reference to the datum, the elevation of the points are measured. This is first objective of leveling. So generally, mean sea level is taken as the datum. With reference to mean sea level, the elevations of the points are measured on the ground surface. Next object of leveling is to establish point at required elevation with respect to datum. That means whenever you are laying a road line or some railway track or maybe plumbing, etc., then the elevation of that points are marked on the ground with reference to the datum, so that the road will be in a alignment. So that is second objective of leveling. That means measurement with reference to datum, with reference to datum, establishment. Both will be obtained. Next, the terms used in leveling. This is a new topic, hence so many new terms will be visible to you. With the sketch, I will explain this one. That is, first term is level surface. What is meant by level surface? It is a surface parallel to the mean spheroidal surface of the earth. You know that the shape of the earth is spheroidal. Hence, parallel line drawn to the shape of the earth is known as level surface. You can see in the figure. This is the level surface. This line is the level surface because our earth is in the shape of a ellipsoid. So the line level surface will be like this one. Next is level line. A line laying on level surface is known as level line. Similarly, second one is horizontal plane. Next definition: horizontal plane through a point is a plane tangential to the level surface. Please see in the figure. This is a horizontal plane. This is a horizontal plane which is tangential to the level surface at point A. At point A, it is tangential to the level surface. Also, another definition, that is horizontal line. It is a straight line tangential to the level line. So at here in the figure, you can see that A point is at some elevation that is passing through one level surface, and B point is passing through another level surface. The difference in elevation between A and B is the level difference between the two level surfaces. Next definitions are there. Some more definitions. That is datum. Datum, it is an arbitrary level surface from which elevations of points may be referred. In India, mean sea level is considered as datum of zero elevation. It is situated at Karachi. With reference to that one, all the elevations are measured. And this line indicates the datum line. C or other level datum. The dash line, blue color dash line is the datum line. Next, mean sea level. Mean sea level is the average height of sea for all stages of tides. It is derived by averaging the hourly tide height over a period of 19 years. So mean sea level is calculated over studying the sea level for 19 years. At every hourly taking the reading, this mean sea level is established as zero. Generally, mean sea level is established as zero value. So with reference to that one, you will measure the heights of the points above the ground level. That means above the mean sea level. So that will be called as elevation of the point or reduced level. Elevation or reduced level is the height or depth of any point above or below any datum. It is denoted by RL, reduced level. In the figure, you can see that the point is that here with reference to the above datum, this value is known as reduced level. The benchmark value of the benchmark is reduced level. Next definitions, mean sea level has been obtained like this one. So by studying the sea level on an average of 19 years, every hour the value is taken. So based on that one, the zero value fixed. That is, this is the datum line. Datum line is fixed at here. Because sea level is not constant, every day it was changing, day and night values will be variable. So on an averaging of the 19 years data, we will obtain the datum mean sea level. Another terms used in leveling. Benchmark. It is a fixed reference point of known elevation with respect to datum. So with respect to datum generally is taken as the mean sea level. With reference to that one, the benchmark is fixed. So benchmarks, different types of benchmarks will be established by the different departments. There is a Geological Survey of India department will establish the GTS benchmark. GTS, Great Trigonometrical Survey benchmark, will be established by the Survey of India department, and other major engineering departments of the state will establish the permanent benchmarks, maybe marked at the site of project or maybe fixed at the department offices. With reference to that one, the benchmark will be carried to the site of construction. And temporary benchmark may be established by the site supervisor. At the closing of a day's work, temporary benchmark may be established at the bottom of a tree or some other borewell point or maybe some important prominent point, so that the day's work can be closed. That is a temporary benchmark. And if any benchmark is not available, then arbitrary benchmark may be selected at some prominent point, and with reference to that one, you can take over the values of the other points. Next definition is line of collimation. It is a line joining the intersection of the crosshairs of diaphragm to the optical center of the object glass and its continuation. It is also known as the line of sight. So two names are there. Line of collimation or line of sight is same. It is an imaginary line passing through the intersection of the crosshairs provided inside of a telescope on a diaphragm and optical center of the object glass and its continuation. So a leveling instrument consists of essentially a telescope. In the telescope, diaphragm is provided in front of the eyepiece. On the diaphragm, these crosshairs are marked, and object glass will be there on the further end, and its optical center and its continuation is called line of collimation. Next is height of instrument. It is the elevation of line of collimation with respect to datum. You can see in the figure. So with reference to benchmark. Benchmark is established with reference to datum. So this line, horizontal line, is the elevation of the line of sight. That is known as height of instrument. Height of instrument is the elevation of the line of collimation with respect to datum. Next is back sight. It is a staff reading taken on known elevation. It is the first staff reading taken after setup of instrument. Next, we'll study about the instruments used for leveling. The following instruments are essentially required for leveling. One is level and tripod, level and tripod, and leveling staff. Two instruments are required. Level is an instrument, optical instrument, and a tripod, telescopic tripod generally provided, and a staff which is marked with the reading. So types of levels, we'll study about the different types of leveling instruments used for obtaining the reduced levels. That is, staff readings can be obtained by using any one of these types of levels. The first type of level is called as dumpy level, and second one is the tilting level and Y level, automatic level. 4 varieties are there, and the fifth one, advanced instrument, is called digital level, is also there. Now we'll see about the dumpy level. First one, a leveling instrument, also called the level, is used for the determination of levels. The dumpy level is commonly used for leveling, designated by gravette. The essential features of the dumpy level are shown in the next slide. It consists of a telescope which is rigidly fixed on support. It consists of a telescope rigidly fixed on supports, and consists of a eyepiece at one end, objective glass at the other end, and a longitudinal bubble is there for leveling purpose, and a cross bubble will be there in the perpendicular direction. And it consists of a leveling head, completely leveling head with a trivate and foot screws and tri-batch. This part is called totally leveling head. And this leveling instrument can be easily tied to the tripod stand with a wing nut or maybe with a threaded end. So fixed tribus, it can neither rotated about is nor can it be removed from its supports. It is very advantageous when several observations are to be made with one setup of the instrument. So this is commonly used instrument for leveling purposes, dumpy level. Description of dumpy level. Tripod stand. The level is fitted to the tripod stand while taking the levels in the field. It consists of a head and 3 legs with pointed metal shows. So leveling head, already had explained in the figure. It consists of a trivette stage and screwed to the top of the tripod when the instrument is to be used. Foot screws. These are important in the leveling instrument. 3 foot screws are, 3 or 4 foot screws are provided. Generally 3 years there between the trivette and the tri-batch. You can observe it here. 3 foot screws are provided. 2 is visible at here. Third one is on the further end. So 3 foot screws will be generally provided between the tri-batch and trivette. That is the leveling head. In between those two, these foot screws are provided. By turning the foot screws, the tri-batch can be raised or lowered to bring the bubble to the center of its run. That means there is a longitudinal bubble right here. This bubble has to be centered by adjusting these foot screws in such a manner that the bubble should be at its center of its run when you rotate the telescope about 360 degrees in the horizontal plane. Like that, you have to adjust the foot screws. Then only the line of sight will become horizontal. Next is telescope. The telescope is fixed vertical on a vertical spindle. The telescope tube and the vertical spindle are cast as one piece. The spindle revolves in the socket of the leveling head. The telescope consists of 2 metal tubes, one moving within the other. That means the distance between the eyepiece and objective can be adjusted by focusing screw. By adjusting the focusing screw, the image of the object passing through the object glass will form over the diaphragm. Such a manner, there is a rock and pinion arrangement is provided inside of the tube, which adjusts the image shall be formed over the diaphragm very clearly. It also consists of the object glass and eyepiece on opposite ends. The diaphragm is fixed in front of the telescope, just in front of the eyepiece. The diaphragm carries a crosshairs. The telescope is focused by means of a focusing screw. Next is bubble tubes. 2 bubble tubes are provided. One is longitudinal tube. and other is cross bubble, are placed at right angles to each other on the top of the telescope or on its one of its side. These tubes contain spirit bubble. The bubble is brought to center of its with the help of the foot screws. Diaphragm. The surveying telescopes are designed in such a manner that the image of the object is always formed in the fixed plane. When the instrument has been focused, the fixed plane at which the image is formed is always made to lie in the plane of the crosshairs in a ring called diaphragm. You can see the diaphragm. This is the diaphragm over which the image is formed. So at here, one horizontal line is there, that is the collimation hair, for which we have to take the staff readings, and one upper stadia and lower stadia is there, and two vertical lines heads are there. In between these two vertical heads, we have to keep the staff for taking the reading. If you want to take only one reading, then horizontal hair, collimation hair reading will be taken generally. Please see. Leveling. The diaphragm ring is held in position in the telescope by 4 fine capstan-headed screws arranged at the right angles. The ring can be given a small amount of movement by turning the capstan screws. The following figure already had shown has a general arrangement of crosshairs on the diaphragm. The middle horizontal hair represents the line of collimation. The two vertical hairs meant for the maintaining the verticality of the staff. It also consists of two additional hairs, one above and the other below the central hair, horizontal hair. These hairs are called stadia hairs, and they are used in stadia tachometry for computing the horizontal and vertical distances from the instrument to that of the staff. Next type of leveling instrument is called tilting level. The tilting level is commonly used for precise and quick leveling. It is similar to that of dumpy level in many respects, but the telescope on the tilting level is not rigidly fixed to the vertical spindle. So in the earlier case, dumpy level, it is rigidly fixed to the bottom spindle, but here it is flexible, not rigidly fixed to the vertical spindle. The telescope can be tilted on a pivot about horizontal axis in the vertical plane, upwards or downwards through a small angle by means of a tilting screw. You can see the tilting screw is there. This is a tilting screw. Same as usual, telescopic arrangement will be there. Eyepiece, objective, line of collimation is mentioned right here, and bubble tube, mirror is there to see the bubble. And only the thing at here, a pivot is provided, a spring return is there. So tilting screw is provided. So approximate adjustment may be made by the foot screws, and bubble is brought to center by adjusting the tilting screw. This is the main theme at here. The telescope can be tilted on a pivot about horizontal axis in the vertical plane, upwards or downwards through a small angle by means of tilting screw. This tilting screw acts against a spring. A pond level is fixed at the upper plate of the leveling head for approximate leveling by foot screws. Exact leveling is done by using tilting screw. The tilting screw is turned up or down till the bubble of the level tube attached to the telescope is at the center of its run. At this stage, the line of sight is horizontal. So tilting screw will be having a gradations on it, and these gradations measure the angle of inclination. That means a telescope can be adjusted so that bubble is brought to the center of its run. The work will be quickly completed, but calculations are very difficult in the case of a tilting level. Hence, this is not used, and this is obsolete now. Next is a Y level. A Y level consists of a telescope held in two vertical Y supports. Two vertical Y supports. The Y supports are curved clips which may be raised to enable the telescope to be rotated about its longitudinal axis. It may be removed and turned end to end. When the clips are tightened, the telescope is held in supports rigidly a level tube is attached to the stage carrying the voice. A leveling head is similar to that of dumpy level, and in some levels, a clamp and a fine motion tangent screw are provided to control the movement of the horizontal plane. You can see the Y level. So two Y clips are there, one at here, another at one. So by removing these two clips, the telescope can be removed from the supports. It can be turned 180 degrees and it can be kept in the opposite directions. That is the main advantage with the Y level. So that testing and adjustment of the instruments is done by using the Y level, one of the advantages. Remaining are same. Diaphragm, eyepiece, telescope and objective end is same. Bubble tube is provided over the bottom, and clamp screw is provided. Tangent is also provided for this one, and leveling head is as usual. Only the thing, a clamp can be opened, and telescope is not rigidly fixed to the base. Telescope can be adjustable. You can see it here. Y level has the advantage of over dumpy level is that its adjustment can be tested rapidly. The disadvantage is that they carries many loose and open parts which are liable to frictional wear. That's why it is not regularly used. Next type of level is automatic or adjusting level. It is similar to dumpy level with its telescope fixed to the tripod. For approximate leveling, a circular spirit bubble is attached to the side of the telescope. For accurate leveling, a stabilizer is fitted inside the telescope, which automatically levels the instrument. The automatic leveling utilizes the action of gravity in its operation. You can see that arrangement inside of the telescope. This is the line of sight. A counterweight is provided so that bubble is approximately leveled, only circular bubble is there, and compensating prism is there. Compensating prism. Even if it is telescope is kept horizontal, then line of sight will fall like this line, horizontal crosshair. Fixed prism is there. These two fixed prisms are there. The counterweight compensating prism is provided here over the counterweight, so that when it is even in the tilt, that means some inclination, the line of sight will become horizontal by adjusting the compensating prism. Please see that one. The prismatic device called compensator is suspended on fine non-magnetic wires. A compensator is an optical system consisting of two fixed prisms placed in the optical path between the eyepiece and the objective. An inverted pendulum supports by four non-magnetic wires operates the compensating prism that keeps the image of the sighted point at the intersection of the crosshairs at D. Advantage with this one is leveling operation can be quickly completed, and the line of sight can be easily established by just leveling the circular bubble. When the instrument becomes approximately level, the action of gravity on the compensator causes the optical system to swing in the position that provides a horizontal line of sight. The pendulum moves until its center of gravity is over the intersection of the lines of the wires supports. This moves the compensating prism so that the horizontal line of sight is brought to the horizontal crosshairs D. Figure C, you can observe that one. Line of sight is horizontal by the compensating prism. It is much simpler to use as it gives erect image. It is very rapid in operation. There is no chance of errors due to bubble setting. The main disadvantage is that it cannot be used in strong winds and at places suspected to vibrations. Some limitations are there for the usage of this instrument. However, it can be advantageously used in the field of construction. Next type of leveling instrument is advanced one, is digital leveling. Digital leveling is relatively new system of determining height differences using nearly fully automatic instrument and methods. This accomplished by the use of pattern recognition imaging system built into the leveling instrument, and the level rods graduated with a special barcode. The user points the instrument at one of the special rods, focuses as clearly as possible, and presses a button to take the measurement. So an image of the barcode is received at the instrument and is correlated to an internal digital image of the rod. This allows the internal software to determine where the level line is intercepting the rod. The height above the foot plate or the 0 point is then computed along with the distance to the rod. You can see the digital level instrument. So by pressing the measuring button after sighting approximately, after doing leveling operation and adjustment of foot screws, focusing, etc., you can sight the object. The barcode is provided over the staff. So the barcode is read by the instrument. With reference to that one, it will calculate the distance of the staff as well as the reading on the staff. So directly digitally displayed, the reading is digitally displayed at here. Even some instruments may be having a recording arrangement so that the reading can also be recorded in the digital level. This is advantageous. However, it operates on battery. So charging of batteries is essential, and special barcoded staff is required for taking the readings. Remaining process is similar, that is leveling operation, etc. is same. Next, coming to the, after studying the types of levels, we must understand what are the fundamental lines of a level. There are 4 fundamental lines of the levels. Those are the line of collimation, the axis of bubble, the axis of telescope, the vertical axis. 4 fundamental lines are line of collimation, axis of bubble tube, vertical axis. Vertical axis is nothing but a plumb line. Line of collimation already had defined. That is an imaginary line passing through the intersection of the crosshairs and optical center of objective and its continuation. And axis of bubble is the line joining the intersection optical center of objective, optical center of eyepiece and its continuation. So both may coincide. That means those line of collimation and axis of bubble tube are parallel to each other, or maybe coincided with each other. And vertical axis and axis of telescope. Axis of telescope. This is also coincides with the axis of line of collimation, most probably. Desired relationship between fundamental lines of a level. So if these relationships fails, then we cannot obtain the correct readings. So these relationships should be maintained. The line of collimation should be parallel to the axis of bubble. The line of collimation should coincide with the axis of the telescope. The axis of bubble should be perpendicular to the vertical axis. The bubble should remain in the central position for all directions of the telescope. Next, coming to the second instrument used in the leveling is leveling staff. A leveling staff is a straight rectangular wooden or aluminum rod graduated into meters and small divisions. The leveling staffs may be 3 meters or 4 meters in length, are commonly used in practice. There is a one brass cap at the bottom and one at the top. The brass cap at the bottom helps in reducing the wear and tear of the base. The bottom of the staff represents 0 reading. The gradations on the staff give the height from the bottom of the brass cap. Each meter is divided into 200 divisions. The thickness of each division is 5 millimeters or 0.005 meters. The divisions are painted alternatively black and white. The meter numericals are generally written in red and on one side, but the decimeter numericals are in black and on the other side of the division. You can see that one. So each division, black one is 0.005 meters or 5 millimeters. The white division is again 0.005 meters. That means each 1 meter is divided into 200 equal parts. 1 meter is divided into 200 equal parts. 100 black and 100 white will be there, most probably. And meters are marked with red color and decimeters are marked with black color. So at the end of decimeters, this is 0.8, this is 0.9, this is 1 meter, like this one. At here 3.9 meters, up to here it is 3.9 meters. So if you want to measure up to here 3.950 up to the back, next to white 3.955, like that one you have to read the instrument from the telescope. This reading has to be taken from the telescope. Staff is kept at a far distance. So the image of the staff is formed over the diaphragm of the telescope. So by adjusting the eyepiece and focusing the objective properly, you can obtain the staff readings. Leveling. So for performing the leveling, first of all, you have to perform the temporary adjustments. Adjustment at every station setup of the instrument, these adjustments are carried out. So generally, three adjustments will be carried out. Two types of adjustments are carried out for the leveling instrument. Those are temporary and permanent. Temporary adjustments are the adjustments which are done at every instrument setting before the observations are taken with the instrument. Permanent adjustments are done when the desired relationship between the fundamental lines of an instrument is disturbed. Once these adjustments are made, they last for a long time. Generally, we'll carry out the temporary adjustments in the field, and permanent adjustments will be carried out by the instrument mechanic. So we must know very clearly about the temporary adjustments of a level. So first adjustment is setting up. As the level is not to be set at any fixed point, the setting up of a level is much simpler than compared to other instruments. Fixing the instrument over tripod, first step. Second step is leg adjustment is done. Third step is leveling up. The purpose of leveling is to make the vertical axis of the instrument truly vertical. This is the important point. Why we should do the leveling is, the purpose of leveling is to make the vertical axis of the instrument truly vertical. That means horizontal line of sight is horizontal. The vertical axis and the horizontal line of sight should be perpendicular to each other. For that purpose, we will do the leveling operation. That means the axis of the telescope and the line of collimation will coincide and forms a perpendicular to the vertical axis. So for this purpose, leveling will be done with the 3 screw heads. The clamp screw of the instrument is released. Clamp is opened. Then turn the telescope so that the bubble tube is parallel to line joining any 2 foot screws, like this one. Any 2 foot screws, 1 and 2. The bubble is parallel to 1 and 2 foot screws. Then rotation of the screws, these 2 screws, that is 1 and 2, will be carried out simultaneously, both inwards. That means one is in clockwise direction, one is in the anti-clockwise direction, so that the bubble should come to its center of its run. Bubble should be at its center of run. Now the bubble is at here. So by rotating inwards, the bubble will move in this direction. Next, turn both the foot screws, that is 1 and 2, inwards to bring the bubble to its center of run. When the bubble is to the left of the center, turn both the foot screws outwards to bring the bubble to the center of its run. When the bubble is to the right of the center. So left to ఉన్నట్లయితే we have to move both inwards, and right ఉన్నట్లయితే outwards move చేసినట్లయితే center వచ్చేస్తుంది. Next, the telescope is rotated through 90 degrees, so that the telescope is rotated to 90 degrees. 90 degrees. That means now the only third foot screw is rotated, either clockwise or anti-clockwise, based on the location of the bubble. If the bubble is at near to the third foot screw, then rotate inwards, anti-clockwise direction. When the bubble is away from the third foot screw, then rotate in the clockwise direction, so that the bubble is brought to the center. And the entire process is repeated. Entire process is repeated. Again, turning telescope to the 90 degrees, parallel to the 1 and 2 foot screws. Above the procedure is repeated till the bubble remains central in both the positions. Now the telescope is now rotated through 180 degrees. The bubble should remain central if the instrument is in proper adjustment. Next, second step of adjustment is elimination of parallax. That is focusing. Elimination of parallax is done by focusing. If the image formed by the objective is not in a plane of crosshairs, an error is called parallax occurs. So parallax error is eliminated by focusing the eyepiece and objective of the level. So two screws you have to adjust. One is focusing of the eyepiece and focusing of the objective. This operation is done to make the crosshairs appear distinct and clearly visible. For focusing the eyepiece, the telescope is directed towards the sky or hold a sheet of white paper in front of the objective. Turn the eyepiece ring either in or out till the crosshairs are visible, sharp and distinct. Next, focusing the objective. This operation is done to bring the image of the object in the plane of the crosshairs. The focusing of the objective, the telescope is directed towards the object. Turn the focusing screw until the image of the object appears clear and sharp. So, after doing focusing of eyepiece and objective, the instrument is ready for setup. Instrument station is set up. Now you can perform the leveling operation. Now we'll see what are the principles of leveling or methods of leveling or simple leveling. First one is simple leveling. Simple leveling is performed when the difference of elevation between 2 points is to be determined, and both the points are visible from the single position of the level. That here figure is given. You can observe the figure. The level is set up at midway between the benchmark of known elevation, and that is a point A, and B point is the unknown point whose elevation has to be found out. So after doing all temporary adjustments at of the dumpy level or leveling instrument at the station L, and then it is sighted towards the staff which is kept over the benchmark, and the staff reading is taken as BS, backside reading, and benchmark value is let's say 100. Then this value is added to the value obtained at here is 0.435. So by adding the reduced level of benchmark, we will get the height of the instrument, that is height of collimation. And then the telescope is directed towards, by keeping the staff over station B, the telescope is directed towards the staff and staff reading is obtained. That is the B point is located in downward direction, hence we'll get the more reading 3.125. So height of instrument, that is a height of collimation, minus 3.125 gives the reducer level of the point B. This is the simple leveling. The entire operation I had explained. So reducer level of B is obtained, height of instrument minus foresight on B. That is minus 3.125. We will get the 97.310 meters, reducer level of B. Differential leveling. Second variety of leveling is called differential leveling. In this method of leveling, which requires more than one setting of the instrument, this method is performed under the following situations. Let us see what are those situations. So when the station A and B are far away, that means from a single instrument station we cannot find out the elevation difference between the 2 points, or they are located at a some intervening ground is there. That means hill is there in between the points A and B, whose elevation difference has to be found out. Under these two situations, we have to go for the differential leveling. In this one, the instrument setup may be there, 1, 2, 3, like that one. Number of setups has to be carried out. 2 points whose difference of elevation is required are situated large distance apart, or the difference in elevation between the 2 points is large, or due to intervening obstacles between the points, then we have to go for the differential leveling. The differential leveling is required in profile leveling, cross-sectioning, contouring, and various other leveling operations. So these are the methods of leveling, that is profile leveling, cross-sectioning, contouring, and various other leveling operations. In that one, in fact, the leveling means the differential leveling, because in practice, a number of settings of the leveling instruments are generally required. It is also called compound or continuous leveling. Looking at reducing the levels, as soon as after observing a staff reading, should be entered in a level field book in the respective column. A level field book or a level book is used for booking and reducing the levels of various points. There are two methods of booking and reducing the levels of point from the observed staff readings. One is called height of instrument method or height of collimation method. Second method is rise and fall method. Now we'll see briefly how the calculations will be carried out and how the observations has to be recorded in the both the methods. Height of instrument method, collimation method. In this method, the elevation of the plane of collimation, that is height of instrument, is found out by adding the backside reading to the RL of the benchmark on which the backside is taken. The RL of intermediate points, the first change point is obtained by subtracting the respective staff readings from the height of instrument. Simply, height of instrument lonchi foresight కానీ లేక ఇంటర్మీడియట్ సైట్ రీడింగ్ అని తీసేసినట్లయితే మనకు రెడ్యూస్ లెవెల్ ఆఫ్ పాయింట్స్ వస్తాయి. సింపుల్. షిఫ్ట్ ద ఇన్స్ట్రుమెంట్ టు ది సెకండ్ పొజిషన్, దట్ ఈస్ L2, and again calculate the elevation of the plane of collimation by adding the backside reading to the RL of change point. Change point means where the staff is kept fixed and instrument has been shifted. By means of backside and foresight taken on the change point, correlate the levels of the two planes of collimation. Find out the reduced level of succeeding points and the second change point by subtracting the staff readings from the elevation of the new plane of collimation. And there is a arithmetical check is also performed, that is a sigma BS in a vertical manner, sigma BS and sigma FS. Sigma BS minus FS equal to last RL minus first RL. And second method, in this method, that is called rise and fall method. In this method, the difference of elevation between the consecutive points is determined by comparing their staff readings. Obtain the rise or fall by calculating the difference between the consecutive staff readings. If the forward staff reading, that is FS, is smaller than the immediate preceding staff reading BS or IS, a rise is said to be occurred. That is positive value. BS minus FS or BS minus IS or IS minus FS is a positive value, then we will treat it as a rise. That means the current position of the staff is at a higher elevation than the previous one. If the forward staff reading is greater than the immediately preceding staff reading, a fall is said to be occurred. So if you got the negative sign at here, it will be fall. The reduced level of each point is calculated by adding the rise or subtracting the fall from the reduced level of the preceding point. Very simple calculation. That is by adding rise. If rise is there, we have to add the this rise value for the previous reduced level. If fall is there, we have to subtract from that reduced level of the previous point. Arithmetical check is there is a 3 arithmetical checks: sigma BS minus sigma FS equal to sigma rise minus sigma fall equal to last RL minus first RL. These all arithmetical checks are only for calculation purpose, but not the observation. If wrong is there in the observations, it cannot be solved at here. Only arithmetical check only performed at here. That is the end. Stop recording.